Let's review everything we learned by looking at some challenges involving strings. The first challenge is to write a program asking the user to enter a date in the format month, month, day, day, and then the 4-digit year. Then instead of printing the month in that format, print it in the European format where you list the date first, then the month, followed by the year. Before you start, create an IPO chart to help yourself plan the project. Give yourself a few minutes where you pause the video and try to think of the answer. First, let's think what should be input for this program. So we're going to need to ask the user to enter a date in the format with a 2-digit month followed by a 2-digit day followed by a 4-digit year. And we want the output for our program to be the date in the European format. So the date first, then the month, then the 4-digit year. And now we need to think about the processing steps that we need to take. Welcome the user to the program. We need to prompt for input of the date. Then we need to create the date in the new alternate format. And to do that, I'm going to need to pull out the 2 characters that represent the month and I'll also need to identify the 2 characters for the date and then identify the 4 characters for the year. And then once I have those pieces of information, I can print the 2-digit date followed by a slash, which will just be a literal value, followed by the 2-character month, followed by another slash, and then finally the 4-character year. So that's going to be my approach for the IPO. If you didn't write the Python for this particular project yet, pause the video now and try to translate these ideas that we captured in the IPO chart into Python code. In Python, our first step is to welcome the user to the program. And we want to follow that by asking the user to enter a particular date as a string. I'm going to use an input function. We want to print, we want them to enter the date in the month first, then the date, then the year. Awesome. And now I want to isolate just the 2 characters that represent the month. And remember, I can use the slice, that's one of the string operations, to isolate multiple characters from within a string. So I'm going to say that the month is equal to the positions within my date to convert string, starting at index 0. And then I want to stop before I get to index 2, because I just want the 2 values at index 0 and 1. So I will stop at index 2. Similarly, I'm going to isolate the characters for the day, and I'm also going to use a slice. And in this case, I want to start at position 0, 1, 2, 3. That's the index of my first character for the date. And I want to stop before character 5. Just when I get the values at position 3 and 4. Those are the 2 for the date. And then finally, the year is the values at 0, 1, 2, 3, 4, 5, 6. And then I want to go to the end of the string. I want to get the values at 6, 7, 8, 9. So I'm going to put 10 here as my final value in my slice. And then once I have those values, I can print the day first, followed by the string literal slash, followed by the month, followed by the string literal slash, and then finally followed by the year. Maybe I'll label that. And I use the concatenation operator here because all of my data values are strings. Everything that I'm printing out is a string value. However, if you wanted to use the commas in here, that would be great too. Both of those will work just fine because we have all string information. So ask me to enter a day. So 10, 12, 2020. And then it prints that out as the 12th of October, 2020. So our program successfully accomplished our goal. We printed the date in the other format. Now let's look at our second challenge. This one asks us to write a program to detect whether a string entered by the user is a palindrome. In other words, is the same characters spelled forward and backward. In order to program this particular algorithm, we're going to need to use a loop to process our string. Take a few minutes and think about how you would process the string and create an IPO chart for this particular program. So first, our input's going to be a string, which may or may not be a palindrome, and that'll be entered by the user. Type in the string to check for palindromeness. And then our output from this particular program is going to be a message indicating that the string that was entered is or isn't a palindrome. And then in my processing step, I'm going to need to iterate through the loop to determine whether the characters kind of moving inward from both outside edges of the string are identical. So I want to know if the first character matches the last character, and then if the character at index 1 matches the second to the last character, and so on. I want to keep doing that until I reach the middle of the string. So my processing, I'm going to welcome the user and prompt the user to enter the string. And then I want to use a loop where I process each character in the string, and I want to check to see if the current character matches the one that's in the kind of analogous position on the other end of the string. I'll say the character at position count is equal to the character at position length minus count. That's my idea. Let's do a little picture to see if that makes sense. So I'll make a little diagram here where we have a string, be 6 characters long. So let's say that our string was A, B, C, C, B, A. That is a palindrome. So let's consider how we might process this. Remember that these individual characters are at various positions within our list. So they're at positions 0 through 5. And I know that I want to use a counter as I process this particular string. And usually the count starts at position 0. And I can also calculate the length of this particular string by using the length function with my string. And that'll tell me that the length of the string is 6. So when I compare the first character, I want to know, is the value at position 0, is that equal to the last element in the list? And it looks like in my algorithm so far, I'm saying check the value at the current position count to see if that is equal to the character at the position length minus count. So length minus count, that would be 6 minus 0. Do we have a position 6 out here? No. So we're going to need to adjust that algorithm a little bit. We don't want it to be the length minus the count. We want it to be the length minus the count minus 1. That's the last index. And that's because the last index in our array is always length minus 1. It's not the index length. So for the first time through the loop, we would be checking to see if the value at index 0 is equal to the value at index 5. And then the next time through, we'll update count to be 1, and we'll be checking to see is the value at position 1 equal to the value at position length, that's 6, minus count, that's 1, minus 1. So it's 6 minus 2, that's 4. So we'll be checking to see if it's equal to this position. And then finally, next time through, we'll be doing 2 and checking to see if it's equal to the value at position length, that's 6 minus 2 minus 1. So in other words, the value at index 3. So we'll be checking these two values. So it looks like we're doing a good job, like we're going to be checking the right values. And then if we keep going for each character in the string, it's going to continue on when the count's equal to 3. Let's see if it gives us the right position to look at when count's equal to 3. We don't really need to check that. We could make our loop so that it was more intelligent and knew that we had gotten to the center of the palindrome and determined its palindrome-ness, either that it is or isn't a palindrome at that point. But just to keep things simple, we could use this loop. And I think it's going to work just fine, even though we process each character multiple times. So if we check to see, is this length 6 minus 3 minus 1, so that's 6 minus 4, so that will be 2. So we'll be comparing this 3 to this 2. And we've already done that, but it won't cause any problem in our program to check it again. Then we'll update the value of count, so it's 4. And we'll be checking to see is the value at position 4 equal to 6 minus 4 minus 1, index 1. So we'll check the B's again. And then finally, we'll update count, so it's 5. And we'll check to see is the value at position 5 equal to 6 minus 5 minus 1, that's 0. So we'll be checking the A's again. So that looks great. Let's check to see what happened if our string had an odd number of characters. In this case, the length would be 5, and we'd be starting the count at 0. We always start at 0. And we want to check to see is the character at position count equal to the character at position length minus count minus 1. So checking to see is the value at index 0 equal to 5 minus 0 minus 1. So that'll be index 4. So that part's cool. Then we'd update the value to be 1 for the counter. And we'd be checking to see is the value at position 1 equal to the length, that's 5 minus 1 minus 1. So 5 minus 2, that's 3. Be checking to see, does this position match this position? And then finally, we want to update it so that it's 2. And we'd be checking to see, is the current value, the one at position 2, equal to 5 minus 2 minus 1. 5 minus 3 is 2. So just be checking to see if this character is equal to itself. And that's just fine. The center character is always going to be equal to itself. So it looks like this is a good algorithm. It's going to allow us to process the characters in the string in the correct way. Now at the end, I need to keep track of something that tells me whether this particular string is or isn't a palindrome. I'll need another variable here, something that allows me to test to see if it is a palindrome. So maybe I'll make an extra variable palindrome where it has the value true if it is a palindrome, and otherwise, if it's false, then print is not a palindrome. All right, so I need to add that variable palindrome into my algorithm, and I'm going to initialize it to be true. And then if I ever get to a character that doesn't match, if say I have like a B over here and a D over here, and I compare them and they're not equal inside my loop, then I'll set that palindrome variable value so that it's false. So if not the same, then make palindrome equal to false. All right, so I think I have a good start to my algorithm. So pause the video for a few minutes, see if you can translate these ideas into Python, and then come back to check your answer. So the first step in our algorithm is to welcome the user. And then we want to prompt the user to enter a string that we want to check. Excellent. And then the next step in my algorithm says I want to set my palindrome variable to be true. I'm doing that so that I can check later on in the program whether it's still true or whether I made a comparison that caused it to become false. Next, I want to write a loop that repeats for each character in the string. I'm going to do that with a count controlled loop. You could use a different technique if you wanted to. There's other ways to solve the problem for sure. And I'm going to keep looping while the count is less than the number of characters in my user string. Then at each iteration, I want to check to see if the value of the character at position count, user string, square brackets, count, see if that's equal to the character at position length minus count minus 1. So it's the user string length minus count minus 1. And if they're the same, actually, we don't want to do anything. It's only if they're different that we want to do something. So I'm going to change this to be if they're not the same, then make palindrome equal to false. And then finally, I need to include my update step for the loop counter. Count controlled loop that always looks like count equals count plus 1. So I've captured my loop body. And now I just need to add in my conditional statement after the loop to print the right value. So if palindrome is equal to true. Oh, whoops, I forgot to put the trues up here. Capitalized to keep Python happy. So if palindrome is equal to true, I want to print out something that says the string, user string, is a palindrome. Then in other cases, I want to print out the string, user string is not a palindrome. Awesome. Let's test this out and see how it works. So if I enter A, B, C, C, B, A, whoops, my length is not defined. Oh, so I used the variable length here to store the number of characters in the user string, and then I just never did that. Never made that calculation. All right, cool. And then if we're calculating that, we can use the same variable down here too. All right, let's try it out again. Excellent. So it calculates the ABC CBA is a palindrome. Let's try it again with another set of input. You should always test more than one time when you're writing your program to try to verify its correctness. Let's try our other example where we had an odd number of characters, ABC, BA. That's also a palindrome. Awesome. And then let's try something that's not a palindrome. ABC, DA. Oops, that tells me user string's not defined. I capitalized it wrong. Let's try that again. So we have ABCDA. And it tells us that's not a palindrome because it's not the same characters forwards and backwards. Fantastic. So our example code that we wrote solves the problem and checks to see whether the user string is or isn't a palindrome. At this point, we've reviewed a lot of information about strings. We understand that strings are actually stored as lists of characters in Python's memory, and that we can write Python statements using input and output. We can use the concatenation operator, the multiplier operator, and the equality test to see if two strings are equal. We also know that we can treat the string as a list and isolate individual character values using the square brackets, just like we can in a list. We can understand that we can process strings using built-in functions that we typically think of being applied to lists, things like the length operator. Those work great on strings and allow us to figure out how many characters are in a string. We also know that we can process a string character by character using a for loop or a while loop that's count controlled. And those are useful if we want to be able to process things for certain algorithms, maybe for something like our palindrome example, or for something like the Caesar cipher example that's in one of the lab assignments, or you might get an upcoming project where you need to process a string character by character to perform some sort of checks on it. And finally, we know that we can convert string values from characters into integers if we need to do that in order to process the string effectively.